Hey there fellow developers, welcome back to our channel. Today we are diving into an exciting fusion of cutting-edge technologies that will take your web projects to the next level. We are talking about Next.js, Hugging Face, and Tailwind CSS. Whether you are a seasoned developer looking to streamline your workflow or a newcomer eager to explore the latest tools, this tutorial is for you. We'll be harnessing the power of Next.js for lightning-fast React applications, tapping into the incredible capabilities of Hugging Face for natural language processing, and styling our projects with the elegance and efficiency of Tailwind CSS. So if you're ready to supercharge your web development skills and build projects that stand out from the crowd, you're in the right place. Follow along as we explore the seamless integration of Next.js, the AI magic of Hugging Face, and the sleek styling of Tailwind CSS. Let's dive in. We are going to start by creating a new folder on our desktop. We are going to call it Paint My Mood, and I'm going to drag and drop it onto the VS Code icon. And this is going to bring up in the VS Code. I'm going to hit Command K and then Z. That is going to bring up the Zen mode, and then Command J to bring up the terminal. I'm going to write npx space create next app @latest /. The // creates the next app within the specified directory. So if I hit Command B, then the directory is empty, which is Paint My Mood that we created. And this is going to populate this with the Next.js application. But before that, it is going to ask for certain configurations. So I'm going to say yes on TypeScript. I'm going to use ESLint, Tailwind yes. We'll be using Tailwind's utility classes to style our web page. Source directory we don't want to use. We would use app router. We don't want to use any custom alias. And it is populating the Next.js application. When that is done, I'm going to go into the app folder and into the page.tsx file. And I'm going to get rid of most of it. So whatever is inside main, I'm going to delete. And this justify between, I'm going to delete this as well. And just check if the app is working, I'm going to write hello world and run this service by hitting npm run dev and hit enter. So that is going to open up in the localhost 3000. So if I open up my Google Chrome, I can go to localhost 3000 and we can see hello world, our app is running. Now to give a heading to our web page, I'm going to write h1 and hit tab. Here I want to write paint my mood as the heading of my page. And also I'm going to show emojis in the page. I'm going to press function key and that is going to bring up the emoji pane. I'm going to use this emoji as well as this paintbrush emoji and give it a space between them and save. And I can see the heading has come up. If you're not on MacBook, you can go ahead and find the paintbrush emoji. So you can go to this Emojipedia and you can copy it and you can paste it as well here. And you can find another emoji which is palette and you can copy it and you can paste it here as well. So that way you'll be getting the emojis. So I'm going to give it a class name, and these are the utility classes that comes with Tailwind. I'm going to give it a text 2XL, so that makes it bigger. I'm going to use font mono and font semi-bold, and I'm going to make the tracking, which is the space between the letters, little tight. So I'm going to use tight as tracking. And for large devices, so if I make the width of the page larger, we can see that this is staying the same size. So let me make it a little bit bigger for large devices. So I'm going to use the large modifier. If the device size is large, then I'm going to use text 4XL. That way when we increase the device size, you can see that it becomes larger. So this is how easy it is to use Tailwind utility classes to modify the styles of our page. So I'm going to go ahead and write a wrapper for the text area. Inside that there will be a text area where the user will be able to input their text, and I'm going to delete all this now. I'm going to come back to that in a while. This text area looks very generic, right? So we want to give it more styling. First thing is that we want to remove this background, and we want to remove the fact that whenever you're typing, it is on focus and this creates a ugly border. I want to remove that, and rather I want to add a border that has some kind of padding around this text box. And for that is why I created this wrapper div class, which will actually have the border. So I'm going to write the class name border and padding of 4, and I'm going to give it a color which is border black. And as you can see, this heading and the text box is doesn't have any gap within it, and we can add that gap by adding a gap class name to the container of the div and the heading. That is the main tag, and here we can add gap of 4. That way we'll have a gap between the heading and the text area. Let me give some class names to this div and the text area so that it starts looking better. So for the div, I'm going to write rounded large. I'm going to make the border a little bit thicker, and for the text area, first, I'm going to give it a placeholder, and I'm going to write type how you feel, and I like to give space between my dots. And for class name, I'm going to give it a display of block first, and width, I'm going to give it the full width of the container, that is the div, and I'm going to give it a text small, so that makes it smaller. And I'm going to change the color of the placeholder a little bit, so I'm going to write placeholder slate 600, and finally the background transparent, because otherwise it looks really ugly. This focus string we have to remove, and for that we can use another utility class for the text area, and that is going to be outline none. So this is how simple it is to style using Tailwind CSS. As you can see, this is a resize hook, and you can drag it to make the text box larger, but we're going to set the height of the text box based on the content that the user has typed. So if the user has typed multiple lines, so we want the text box to also be responsive to that. We want the height to be automatically increasing. For that, I'm going to create a state variable. So I'm going to create a section for state variables. So I'm going to create more space by hiding this sidebar. So I can hit Command B, and that is going to hide the sidebar. And in the state variables, I'm going to write state snippet and use state snippet. So I can hit tab, and that is going to allow me to type the name of the state variable. I'm going to write rows, keep it simple, and then hit another tab. That is going to allow me to set the initial value for the state variable. So I'm going to write 2 here and import useState from React. So when we import useState, obviously you'll get an error on our page because these are client components, and you will have to write use client if you are using useState on top of the component where it is used. So I'm going to write use client and refresh this. Now in the text area, I can say rows is equal to the rows that we have as a state variable. Now whenever we change the rows, and we'll be changing it whenever the user types new text or new lines, this text box height is also going to increase. So let's do that. Let's write a onChange handler on this text box. So I'm going to write onChange handle input change, and I'm going to place my cursor on it and hit command dot. I'm going to add missing function declaration. That is going to make sure that we already have the required type or parameter added in the function name. So I have to import change event. I can place my cursor on it and then hit command dot and update import from React, and that's going to fix that compilation error. And I can delete this line, and here in the event object we'll have the text that the user has input. And so to store that input, I'm going to create another state variable. So I'm going to write state snippet and input, and the input is going to be a empty string initially. So this is going to store the user input that the user types in the text box. And I'm going to write set input and event dot target dot value. So whenever a user types in the text box and the value changes, this method is going to be called, and that in that event we will have a value that we are setting it and storing it in the state variable for the component. So the way a states work in React is that we get a method using which we'll be able to set the value for the state variable, and whenever that value changes, React is going to make sure that whatever component is using that state variable, that gets re-rendered. For example, if we want to show this input right under this text box, then the way we do it is that, so we'll add a p tag here and we'll just write input. That way whatever input is stored in that state variable is going to be shown, and whenever we are setting this input, React is going to make sure every time it is reset, it is going to re-render this part so that this updated input is shown on the page. That is the reason for us to use the state variables as opposed to using a plain old variable. So if I type something here, so actually I put it inside the div. So if I place it outside it and save it, and then I can write I feel good, that way we'll be able to see that whatever I'm typing is shown there. I'm just going to add a greater than sign here just to denote that this is what the user has typed. So finally, in the handle input change method, we have set the input. Now we can set the height of the increase. We can check if it requires us to increase the number of rows if required, and we're going to write a simple logic here. We're going to say const new rows, which will be basically set as the number of rows, and we're going to say math.max, which is basically our way of making sure that we at least have one row. So max 1 and something else, that means the minimum value has to be at least 1. After that, we want event.target.scroll height. So if we hover over the scroll height and then click on this MDN reference and click on open, so you'll see that element.scroll height is a read-only property that is a measurement of the height of an element's content, including the content that is not visible on the screen due to overflow. So that is a typical case for a text box, when you type some more content, there will be a scroll bar visible. So we want to find out what is the actual height of the content, and this scroll height gives us that value. And if we say that each line is of 20 pixel height, then we're going to divide that height by 20. That is going to give us the number of rows that are required. Now this can be a decimal number, so we're going to truncate that value by writing math.ceiling. So this is math capital dot ceiling, and we're going to wrap it in this function. That way we are making sure that the number of rows that we're getting is going to be a numerical value, and that value is going to be at least 1. And finally we're going to set that as our number of rows. So I'm going to write the set rows, which were given to us when we created the rows state variable, and we're going to set that rows variable using the set rows method, and we're going to pass on the new rows to it. And that way, if we refresh our page, whenever we type new content, and we don't even have to add any return to this. If we add return, it increases the height, but if we just keep typing without adding return, it is going to detect the content height that is required, and it is going to make sure that the rows are set accordingly so that the height of the text box also increases. Now this hook is still there, using which you can change the height of the text box. So let me remove that using Tailwind utility classes. So what I can write in the text area is that resize none. So that way that hook is going to go away. Now whenever the input changes, we want to make API calls to our backend API, and that is going to handle the running of the inference. For that, what we're going to do is that we're going to use useEffect. So the way useEffect works is that whenever the state of the component in a React app changes, useEffect is going to check if we have mentioned a specific code to be done in such cases. So I'm going to write useEffect snippet, and I'm going to come to this return statement in a while. But the way useEffect works is that, so first we'll have to import it from React. So I'll keep my cursor on useEffect and hit command dot and update import from React. So in this array, we get to define the dependency of the useEffect. So if we keep it as empty, that means this useEffect hook, whatever we write here, that is going to run only once when the component loads. But we can mention specific state variables here. For example, if we write input, so every time input state changes, whatever is written here, that is going to run. So you can say useEffect is basically a code block that runs as a side effect of a changed state. So whenever input is going to change, we are going to run the predictions based upon the input that was typed in. So we're going to do that after a certain delay, after the user has stopped typing. So for that, I'm going to use the timeout function. So I'm going to write set timeout, and I'm going to give it a 1 second delay after the user has stopped typing. And then I'm going to do run predictions, a function that we haven't defined yet. So let me define that function first. But it is going to create a bug here. So if we set the timeout, so let's say I write I feel good. That way, whenever I start typing, let's say I have just written I, then it is going to create a timeout function with 1 second delay, after which it is going to run the prediction. But it does not detect the fact that I have not yet stopped typing. I am still typing, and I type space, and then also it detects that the input has changed. It is going to create another timeout function with 1 second delay, and then I type F, and then again it is going to detect the input has changed, and another timeout is going to get created. So if I just type up to I space F, it is going to create 3 timeout functions, and it is going to run 3 predictions. So for that, what React offers us is that whenever this input changes and this code block runs, it is also offers us a clearing statement using which we will be able to clear whatever we did in the earlier call of this code block. So if you save this timeout object that gets returned from this set timeout function, then we can ideally clear this timeout function every time this input changes, and only after the last character has been typed, only after that timeout does not get cleared, 1 second passes, and then only run prediction executes. So that is the expected behavior. So I'm going to write the clearing statement by writing return, and it expects a lambda function. And here I'm going to write clear timeout, and I'm going to save this timeout in a timeout variable. I'm going to call it input timeout, and I'm going to pass on that input timeout here in the clear timeout. That way, whenever we have typed the last character and 1 second has passed, then only the run prediction function is going to be called. And here we are going to hit the backend API with the input text to run our inference. So I'm going to first check if input exists. So I'm going to make sure that the input is not blank. Then I'm going to call API send API call. But before that, I'm going to show a loading indicator to the user. And for that, I'm going to create another state variable. I'm going to call it loading, and it's going to be false initially. And before API call, I'm going to set loading as true. And after the API call, I'm going to set loading as false. And using this loading value, we'll be able to show a loader on the page. So to send the API call, you can use fetch, but I'm going to use Axios because Axios makes things very easy. So I'm going to stop the service by hitting Ctrl+C, and then Command K is going to clear the terminal window. And then I'm going to write npm I stands for install Axios. And after that is done, I'll be able to use Axios. So I'm going to write const response is equal to Axios. It gets auto imported, and then post. It takes API name, and we haven't created the API yet. So I'm just going to write the name for now. And then, so in the post, we'll also be sending a JSON object. So that will contain the input of the user. So the key is going to be input, and the value is obviously going to be input, which is the state variable value that we have. Now, since the key and value has the same name, we can simply use input here. Now let's go ahead and define this emotion API that we named it. Obviously, you could use a better name here. So I'm going to bring up the sidebar by hitting Command P, and then go to this app. And then I'm going to click on this new file and type API/emotion/route.ts. And that is going to create a API directory within the app directory, and then an emotions directory within it, and then a route.ts file within it. So the way this API works is that we use by convention method and not by configuration. So when we create this folder structure, React is going to detect that there is an API that exists. So it is going to see that there is a route.ts file exists, and this name is important. Route.ts file name is important. So whenever it sees that there is a route.ts file that exists, so that means that React knows by convention that there will be a API that exists with the API/emotion name. And inside this route.ts, we'll have to export a method or a function with the name post, so that we can send post request. If you want to send get request, then you also will have to create a method called get. And I'm going to write post here. That way, we'll be able to send a post request to this API. So this post request is going to take a request of type request as parameter, and is also going to have a response of type response. And this has to return a response. So I'm going to write new response. I'm going to have to return new response. And here I'm just going to write dummy response for now. And I'm going to send the status as 200. If I refresh our page and write that, and after 1 second, it is going to send a request to this API. Actually, let me print that response. This actually returns a promise, and we can await it. And that way, obviously, we'll have to make this wrapping function async function in that case. If we save it, then that error gets resolved, and we'll be able to print this in the console. If we refresh, I feel good. After 1 second, we hit the API, and then we get a response back. And the data object is basically a dummy response, as we have returned here, and the status is 200. Now let's do one thing. Let's get the input from this request object out, and hit the Hugging Face inference endpoints to detect the emotions associated with that text. To get the input that we passed along, I'm going to write const body of the response of the request. So I'm going to write request.json, and this is also an async function. So I'll have to await it, and that means that we'll have to make this wrapper function, which is a post function, an async function. And now this body, as we know that we have passed along, the body is nothing but an object with input as key and value pair. So we can actually destructure. The value pair does not matter, because we know that there is a key that exists with the name input. So we can destructure it as input, and in one line we'll be able to get the input out of this body of the request. Now to run inference from the text input, I'll go to Hugging Face, and I'll urge you to go to the docs section. And if you're a Python developer, this is the transformers library that interests you. This allows you to pull the Hugging Face models onto your Python notebook, for example, and then run inferences based upon that. But as web developers, we are most interested in Hugging Face.js library, which allows us to hit these inference endpoints that are hosted in Hugging Face and get inference back. So I'm going to click on this, and then I would urge you to go to this use inference endpoints. So that is going to tell you that you first install npm package. Obviously, you can use yarn to add that package onto your project. Then it's very simple. You just have to create an instance of that HF inference object, And using this HF inference object, you'll be able to hit the API endpoints in the backend. So let me show you some examples how Hugging Face makes it so simple to run these inferences. So let's say we are talking about the text summarization task. So there are multiple type of tasks that you can run, and there are different models that accomplishes those tasks, right? So if I go to this models page, you'll see that Hugging Face right now has 494,000, which is going to be 495,000 very soon. And I'm pretty sure that by the time you see it, it is going to be much higher than this. So on the left side, you'll see that these are the tasks that these models accomplish, and for each task these are actually filters. So if you click on text classification, you see the models that accomplish that specific task, and you have different types of tasks, like for example multimodal feature extraction, image to 3D, text to video, computer vision tasks. We have text classification, which we'll be using. So the best part is that all these tasks can be accomplished using this Inference API in a very consistent way. By that I mean that the way you'll be accomplishing a task, for example text summarization, will be pretty similar to accomplishing a task that is text classification or sentence similarity or a audio task. So as you can see, the tasks that you will want to use will actually be called as a method on the Hugging Face inference object that we created, and then you'll have to specify the model name within that, and then additional parameters that the task requires. As you can see, for audio, you just call that audio to audio as a function on the Hugging Face inference, and you specify the model name and send the data, that is the audio data, in the data parameter, and that way it will be done. And similarly, for example, text classification, you can just call hf.text classification and then give the model, and for this you can just specify the inputs and give it the text, and you'll get the response. As you can see, this API is very consistent across different tasks classes. That is the best part I like about Hugging Face, that it makes it very easy for you to handle all these different tasks and different models in a very consistent API. If I go to text classification, this models basically classifies the texts on positive, negative or neutral, but since we are more interested in the emotion or detecting the emotion behind the text, so that is why I'm going to search for emotion. I'm going to choose the Roberta Base Go Emotions model, and as you can see, this is a very popular model at this point. It has about 10 million downloads in the last month. So you can test out these models using this window. So as it gives an example, I'm not having a great day, you can type your own text here and hit compute, and you can see that it is detecting that it has 50% disappointment, 34% sadness, and this is an ordered list. Obviously it has about I think 28 emotions listed, and it assigns scores and gives you an ordered list in a descending order of the scores that it assigns to each of those emotions. And you can see the JSON objects that you'll be receiving. So if you click on this JSON, for some reason, I don't know, whenever I click on this JSON, it refreshes the page. So I have found a very interesting workaround. I click on this maximize and then go back, and that way I'm able to see this JSON. I think they should fix this bug. And so as you can see, this gives us an array, and it has a label which is the emotion, and then a score is assigned to this emotion, and this is an ordered list. That is actually very good, because we are probably most of the times interested in the top 2 or 3 emotions, and we don't care about the emotions that got very low score for that specific text, of course. So this is the Inference API, which we will be hitting from our Next.js application, and we'll be getting this inference response back in this JSON format. So with that knowledge, let me go ahead and install this inference endpoint as a npm package, and then try to hit this inference endpoint. I'm going to follow their instruction here. So basically they have asked us to install this npm package, and you can also use yarn to add this npm package. I'm going to copy this code. I'm going to stop the service, clear the terminal, and then run this command. After that is done, I'm going to initialize. So I'm going to first import and then create a new instance of this HF inference object that comes from this npm package. I'm going to copy this and paste it on top of the API that we created, and it requires an access token, as you can see. So they mentioned that the access token is not mandatory, but eventually you will be rate limited. It asks, or at least recommends, that you have an access token. If I sign out and if you log in, so first time you will have to sign up, and you can sign up using your email address. I already have signed up, so I'm going to log in, and you'll have to click on this profile picture of yours, and then go to the settings section, and then access tokens, and you'll have to click on new token, and I'm going to name it Next.js tutorial, and I'm okay with read right now, and generate a token. And here I can click on this copy, and that is going to copy this onto my clipboard, and I'm going to create a .env file on the root of my Next.js project. This is very standard approach, and I'm going to name this token as HF token. This name can be anything, but this text is what we copied. So make sure that whenever you copy this text, you keep it safe and you don't want anybody to use it. So for that, it is best practice that whenever you add a .env file, you also add it in the git ignore. So when you'll be publishing this onto the GitHub, you don't want this .env file which have all these API tokens. You don't want them to be published on GitHub. So it's best practice that you always add this .env file. As soon as you add this .env file, you add this in the git ignore file. So I'm going to save it after adding it. I'm probably going to delete this token from my account here. I would urge you to create your own token and not use this token because it might be deleted by the time you watch this video. So with that, I'm going to go back to this route.ts, which is the API that we were creating. And here I'm going to write process.env and we named it as HF token. And that way we'll be able to create the instance of this Hugging Face inference object. Now, if we go back to that docs for Hugging Face.js and use inference endpoints, we see that we'll be able to call those tasks as methods on this object and we'll be able to run inference. So we are talking about text classification. So I'm going to create a different function for this. I'm going to name the function as run inference, and this is going to be an async function, so we'll have to await it. And I'm going to make sure that we are returning the inference. So I'm going to write const inference response, and I'm going to create this function here. This is going to be an async function. This is going to take the input as parameter, which is going to be of type string, and I'm going to pass the input here. So here we're going to check if the inference object has been created. So for that, what I am going to do is that I'm going to delete this line from here and define HF as an object, and the object is going to be of type HF inference, and I'm going to check if HF exists. If it doesn't exist, then I'm going to create this and I'm going to paste it here. So this is not going to be a const, it is going to be a variable. So I'm going to define it by let so that we can assign the value here. And then using this, we'll be running the inference. So first I'll define the model name, and I'm going to copy the model name from here. So we chose this model to detect emotions. I'm going to click on this copy button and we can paste it here. And then I'm going to write const inference response. I'm going to await hugging face dot, and these are the tasks that we can accomplish. And we are talking about text classification here, and it takes a config object where the first thing we'll define is the model, and that will be the model name that we have defined there. And then it is going to take inputs, and this is going to be, so each of these text classification and everything are typed functions. So that is why you get these TypeScript errors if you don't specify the inputs or whatever the parameters that are available for this config object. So this is very difficult to go wrong in this specific case actually, if you're using TypeScript and if you're using this specific npm package which sends requests back to this inference endpoint. So I'm going to write input, which we received as a parameter there. And since that is string and it expects a string, the TypeScript is happy, and that means that our code is going to work. And then finally, after this is done, we are going to return the inference response that we are going to receive from this API endpoint, and that is going to be the function run inference. So if I console log inference here to make sure that we are receiving the JSON object as we thought we would be. So let me save it here. Let me run this by writing npm run dev. And if we refresh our page and go back to the server, so I'm going to say I feel good. So first time it is going to spin up the instance that is there in the Hugging Face. So it is going to take few more seconds than what it should, and then we'll be receiving the response. So basically this has sent a response back using this API endpoint, and we have received the inference response and we are console logging it here. So as you can see, the weight for joy is 83% and the admiration is very low. So it's basically a joyous statement we are talking about here. So after we receive the inference response, I'm going to filter this array, and we could actually get the first top 2 or top 3 emotions. But as you can see in this specific case, admiration and approval are not very relevant. It is mostly joyous, and we can do that by the following logic, that the first one is going to be always true. The first emotion is always going to hold. But the next one is going to be compared against the score of the previous one. So I'm going to set a threshold 50%. So if the subsequent emotion score is less than 50% of the previous one, then I'm going to ignore that emotion and anything that comes after that. Since it is 83% joyous, then that means if the subsequent emotion comes with a score of at least 42%, which is not going to be the case because that is going to be more than 100%. But that is the logic I'm going to use, that if the subsequent score is at least half of the score, then that emotion is going to be filtered in. If not the case, then that emotion is going to be filtered out, and everything that comes after that, because this is an ordered list. For that, I'm going to write a different function. I'm going to say const filtered response, and filter responses is the function, and here I'm going to pass the inference response. If we pass this inference response as it is, this is going to pass the reference of that array, but we want to create a copy of that, and so that we don't modify the array that we received from the Hugging Face Inference API. So we are going to do that by writing ... in front of the inference response array, and that is going to create a copy, and that is going to be sent to the filter response function. So let me write the filter response function. So I'm going to write function filter response, basically filter responses, and that is going to take an array. This will be emotions, which will be of type array, but I don't want to define it like this. So this is a specific type, which is text classification output, which we printed here. So as you can see, that is an array. So I'm going to preserve that type here. So I'm going to copy this text classification type. That is going to be the type that we'll receive after we await it, and we'll have to import it. So if I place my cursor on it and then hit command dot, I can update the import from Hugging Face, and that is going to be imported from that npm package that we installed. And this type, I'm going to use this type to type the function here. This type is indeed actually an array, as we can see after printing it, and that means we'll be able to loop over these emotions and filter the emotions. So first we'll write const filtered, which is going to be an empty array, and this is going to be returned at the end of this filtering. So first thing we're going to get is the emotion 0. So basically the first element in this ordered list, and that is going to be the emotions dot shift. So since we created a copy of the array that we received from the Inference API, we can use the destructive methods like shift, which is going to remove the first element from the array, and it is going to return it and store it in the emotions variable. And the first element always gets pushed into the filtered array. So that is what we're going to do. Filtered push the emotion, no matter what, the first element always gets to be pushed into the filtered array. And then we are going to define this score variable, and we're going to set it with the first emotion score. And now we are ready to loop over the rest of the components. So I'm going to write a while statement here, and since we are using destructive functions like shift, that is going to reduce gradually the size of the emotions array. So we can check if the emotions array length is greater than 0. As long as it is greater than 0, we're going to run the while loop. So I'm going to write emotion I, that is the ith element that we are going to get by writing emotions dot shift, another destructive function that is going to pop the first element and store it in this emotions variable. And then we are going to check with the if statement if emotions I dot score is greater than the score that we stored there. So for this error, this is saying that this can be possibly undefined. So we can use the assertion operator of exclamation, and then we can use the same assertion operator here, and that's going to remove that error. And we're going to set a threshold that is going to be of 50% of the score. So basically we're checking if the score of the emotion that we are assessing now, if the score is at least 50% of the previous emotion score. If that is the case, that means this emotion gets to be pushed into the filtered array. So emotion I gets pushed, and the score is going to be reset. So this is now the benchmark score for the subsequent emotion, and we're going to say emotion I dot score is the next benchmark score, and we're going to repeat this while loop. And if the score is not greater than the 50% of the previous score, then we don't want to assess any other emotions that is down the line. So we're going to say else. We're going to write a break statement that is going to break out of the while loop. And after the while loop is done, we are ready to return, and we're going to return the filtered array. So this is going to be the filtered response for us. And finally, when we're returning the dummy response, we're going to return a JSON object. And the way we return JSON object is by stringifying them. And we're going to write JSON stringify, and the object is going to have two keys. One is inference response, and another is the filtered response. Now, obviously, we could write as key value pairs. The key is inference response and the filter response is filter response. But since the name of the key and value are same, I'm going to just use the name of the parameter which stores it. Now, if we refresh this page, and if I type I feel sad, then we are going to get the response back. And if you see this data, you will see two objects. One is filtered response. Well, I just realized that I used 0.05 here, which is basically means 5%. So let me set the threshold as 50%, and then I'm going to refresh the page and I'm going to write I feel sad, and the response is going to have two keys. One is filtered response, which is going to say it is sadness, and then inference response is going to have the same score for sadness, and the other is other emotions as well, which are not relevant for this text. Now with that, we are ready to show these emotions as tags and assign emojis for those emotions and set the background of the web page based on the tagged emotion that we received. To show the output, the way we created input, I'm also going to create another state for output, and I'm going to initialize it as undefined. And when we receive the response, as we saw that the response has a data object and then filtered inference tag. So I'm going to set that as output. So I'm going to say res.data.filtered response. And I'm going to say that the output is basically of type array. So that way we'll be able to loop over this output. So this filter response is actually, we are getting it as an array, and then we are setting this type so that we can write map function on this, and TypeScript does not complain. So after this p tag, we're going to write a div with class name flex wrap, items center, justify center, and within each of those tags, I'm going to give it a gap of 2. And then we'll be placing each of those items as tags. So I'm going to loop over the output, and we get this map as IntelliSense because we typed the output as an array. So we're going to say map, and this is going to take an object. And as we know, this object is going to be basically the emotion. So we can destructure it. Each emotion, as we know, has a label and a score. Now this TypeScript does not detect it. So we'll have to also add this in the type of the output. So the output type, we're going to define it as, and this is only because of the TypeScript. If you're writing it in JavaScript, this will not be the case, but TypeScript being a strongly typed language makes sure that we get less runtime errors. Because JavaScript is an interpreted language and it is prone to runtime errors. TypeScript makes sure that we catch most of those errors in the compilation time. So that is why I like to use TypeScript. But it might look like an overhead, but this actually comes with a lot of benefits, like you get IntelliSense and you make sure that we get less runtime errors. I'm going to write label, which is of type string. Obviously, there are better ways of doing this, I'm pretty sure, but this is how I'm going to do it for now. So I just typed it as an array of objects, where each object is going to have a label of type string and a score of type number. So within this, I'm going to loop over this output. So I'm going to write output.map. So this is going to be a lambda function, and this is going to be emotion, which is basically going to have a label and a score. And here we can return any JSX fragment. So for example, for now, let me add a span, and within this span, we'll be able to use this label. We are not going to show the score, but we want to show the label and an emoji that is associated with the label, which is the name of the emotion. So whenever we loop over an array and show multiple elements, React expects that you create separate identifiable keys for each of those elements. So that is the first thing we'll do. We'll use a label as the key for each of those elements, and we're going to use the utility classes of Tailwind. We're going to start by writing cursor as pointer, and background, I'm going to give it a slight indigo background, and then text is also going to be indigo, but a much darker indigo. I'm going to give it a text of large, and padding x of 4, padding y of 1, rounded full. That's going to give us the rounded view on the both sides that we usually see in tags. And then I'm going to give it a border and set the border color as indigo 400. And inside that, I'm going to show the label. If we refresh our page and write some text, I don't know how I feel. That means it says it's confusion. So our tag is working. Now let's add an emoji for the tag. So each of these emotions will be associated with a specific emoji, and later also we'll be setting the page background according to the emotion that is tagged. And for that, I'm going to create config file. So I'm going to bring up the sidebar window, and in the apps directory, I'm going to create a new file, config.ts, and here we'll be basically writing the configuration for each of those emotions. For example, if it is anger, then probably it is associated with a slight red color and it is associated with an anger emoji. To create that config file, what I did is that, so if I console log this output again and write I don't know how I feel, and if you see the array that we received, it is going to be an array of JSON objects. So what I did is that I copied this inference response, I pasted it on ChatGPT and asked like extract the texts like confusion, neutral, realization, etc. and give me a comma separated list. And after that I have asked it to assign it a color, and I've asked it to use popular cultural reference in doing that, and then asked it to assign a hex code for each of those colors, and then I have asked it to assign a single emoji that denotes that emotion. And finally I have asked it to put all of this in a JSON object format, and I got the response which I'm going to paste here. So this is the response that I received after doing all those things in ChatGPT. So as you can see here, inference response is actually coming as an array of 28 objects. But while prompting, I have made sure that I am getting a JSON object where the key is basically the label that denotes the name of the emotion. So that way we will not have to use indexes like 0, 1, 2 to get the name of the emotion. Rather, the name of the emotion itself will be a key to this JSON object, and we'll be able to get the hex code and the color name and the emoji that are associated with that specific emotion. You can find this code in the GitHub repository that I'm going to post the link under the video. So back in the page, when we have written the label, after that label we are going to show the emoji. So we're going to give a space and then write emotion config, and this is going to be auto imported at the top of the page, emotion config. And I'm going to use the label as a key on that object, and then dot emoji is going to give us the emoji that is associated with that emotion. Now this is again a TypeScript is complaining, but we know that this type exists, so I'm going to explicitly define this object as any, and then that error is going to go away. Now as you can see, this is confusion, so this is the emoji that it assigns it to. Earlier I actually set the background color with the color associated with the emotion itself, but then I decided that setting the background of the page will be a better option. And in that case, obviously if the background and the tag has the same color, then it would not pop. So in that case I had to go for a specific color, indigo, for the tags, and the color of the background would be set according to the emotion that has been detected. So let me do that next. To handle the colors, first I will create a variable called const default color. So this is going to be a default color of the web page, and I'm going to just give it a slight gray, and that is going to be 999999. And I'm going to define a state here with name color, and the initial value will be the default color. And in the JSX part, in the main component, I'm going to write style double brackets background color, and I'm going to set it with the color that we have stored in the state variable. So if you save it, you see that this is the color that we get. I think this is a little too dark, so let me set it as AF5, A5, A5, AF, AF, barely changes anything. Well, let's settle for CC, and that is a slight gray that is going to be the default color for the page. Now, whenever the output changes, we want to set the color based on that, right? So this is going to be a side effect of changing the output. So we're going to use the use effect here, and the dependency is going to be output. So whenever the state variable, that is the output, changes, this code block is going to run as a side effect of that change. So here I'm going to write handle color, and I'm going to create that function, and I'm going to check if output exists first. If output exists, and if output dot length is greater than 0. So here we are going to set the color according to the primary emotion that were detected. So that is going to be in the output dot basically the first element of output, and the label of that is going to be the emotion that was the primary emotion that were detected, and I'm going to use that as the color key. So I'm going to name it as color key. To resolve this error, I'm again going to explicitly type it as output as any array, and then take the first element and then the label of that as color key. And to get the hex code, I'm going to write color hex is going to be, again I'm going to strongly type it, whatever I used here, and replace the label as the color key, which is basically the label that we extracted from here. And the emoji, in place of emoji, we'll use, let me check the name again. So if I go to the config ts, I'm using color hex. So we'll use color hex to get the hex code, and then set color, the color hex. So if I refresh this, and if I say I feel sad, so this shows a blue color. Let's see if I write I feel angry, and this is going to show a red color. So what if I feel energetic? So as you can see, there are 3 emotions that were closely detected. and joy is the most prominent emotion, so that is why it is showing a bright yellow color. Now one thing is that as you can see, this changing of the color is very sudden, and I want to add a subtle animation to this, and we can easily do that using Tailwind's built-in animation. So I'm going to go to the main tag where we have set the background color based on the state variable, and here I'm just going to add transition all. We can also add transition colors that would add animation to the changing of the color, but I just added for transition all, that is also including the changing of the color. So I'm going to refresh this page and write I feel sad, and as you can see, this is changing with a slight fade in effect. I can write I feel angry, and the color change is little subtle, or rather if I say I feel happy. So let me add a little bit delay to this animation that is going to elongate the process of animation. So I'm going to write delay of, this is 500, and if I refresh, and I'm going to write I feel down, and that's going to bring in the animation with a little bit of delay. And if I write I feel upbeat, that's going to fade in that color change. Now I think these colors are too saturated, so let me add a little bit of opacity to this background color so that it does not pop as much as it is doing right now. So we have a hex code, and if we add 2 more digits to this hex code that starts from 00 and goes up to FF, and we can define the opacity or rather the alpha value of that color. So I'm going to add a alpha value of 55. So that is going to make this color much more subtle. If I add a little bit more saturation, let's add AA, that's going to add a little bit more saturation to it. And let's see if I use the vibrant color of anger. Yes, this is going to be a little bit more subtle version of the red. Now let's add that same fade in and out animation to these tags. So for that, I'm going to create another state variable, state snippet, tags visible, and this is going to be false initially. So, and we're not actually setting the visibility here, so we'll be doing that using opacity. When we'll be changing that opacity, this will also be using the transition all utility class that we used, so that when the opacity changes from 1 to 0, that also adds the fade in and fade out effect for those tags. So let me do that. So when we define these tags, first I'm going to add transition all to this span, and I'm going to add a style attribute here with double curly braces, and I'm going to add opacity, and I'm going to check if tags visible is set to true. If this is true, then set the opacity to 1, otherwise set the opacity to 0. And now we'll have to set this tags visible state variable using this method, and whenever we set and reset, the opacity is going to change for those spans, and that is going to fade in and fade out using the transition all utility class that we wrote in the spans. So whenever we are running the prediction and we are setting the set loading to true, we are going to hide the tags. So we're going to say set tags visible to false, and whenever we have received a response and the loading has completed, we are going to set tags visible to true. Now if we refresh the page, if I write I feel sad, you see the tag comes up, and then if I write I feel angry, it goes away with a fade out effect, but the fade in is not working. So if I write I feel lost, the fade out is working, but the fade in is not working as expected. So what happens is that when you use these methods of set output, set loading, and set tags visible, these are going to set in an asynchronous way. It is not going to set right at this moment. So when this line is executed, you cannot assure that the tags has been set after this line. So as you can see, we are setting output, and then next right after that we are setting the tags visible. So all these settings are going to be run in an asynchronous way. We are basically setting the output in the state variable, and we are looping over that output. So in an ideal case, if we have rendered the output first and then we are setting the tags visible, in that case we would be able to see the fade in effect. What is happening is that due to this asynchronous nature, the tags visible has been already set, but the rendering has not happened yet. So when the rendering is happening, at the time the tags visible is already set to true, and this is going to come with the opacity 1. But in ideal case, what we want is that the opacity should be set to 0, and for the fade in effect to work, that 0 has to be transformed to 1 after this rendering has happened. But due to this asynchronous nature, tags visible has been already set when this rendering is happening. So that means this is going to come, the opacity is going to come with the value of 1. To avoid that, we cannot set these tags visible here, and what we'll have to do is that we'll have to execute this step as a side effect of setting this output. We don't want to explicitly set it after the output has been set. We're basically telling that whenever this output has been set, we want to set the tags visible as a side effect of setting up that output. So what we're going to do is that in this use effect hook, when we are also doing the handle color, we're also going to set the tags visible to true, and that way whenever the output changes, so basically whenever we are setting the output here, after that when the output has changed, that time we are setting the tags visible as true. So now if we refresh it, and if I run I feel sad, we see the fade in effect works, and if I write I feel angry, it fades out and the next tag fades in. That is the expected behavior. Now as a final step, whenever it is hitting the API, I just want to show a little loader icon just below it so that the user knows that it has to wait in case the inference takes a little longer to run. So for that, I'm going to use an external library called React Loader Spinner. So you can search for React Loader Spinner and go to the first link. As you can see, this is already a very popular library, and you can see the getting started guide or the spinners that are available. It's pretty simple to use. You can see that they have something like this audio, we have ball triangles, we have DNA. I have used this library before, and this is I find it very easy to use, and I always find some kind of loader that suits the purpose. So here I'm going to use the coloring, and if you come to the npm documentation, you can see that you can install it using this this command. You can add save, but this is not required anymore. Okay, let me just copy that, and I'm going to close the service by hitting Ctrl+C and then Command K to clear the terminal, and then I'm going to write that command and bring up the service by writing npm run dev. Now I'm going to go to the JSX segment of my page, and right after this last div, I'm going to check if it is loading, and we have already set the loading before we are sending the API request. And if it is loading, I'm going to write it as a separate function, loader, and I'm going to write it here, function render loader, and it's going to return a JSX fragment. And in this, I'm going to copy this coloring code. I can replace the JSX fragment here, and I have already installed this component, so I'm going to place my cursor on it and command dot, that is going to add an import from React Loader Spinner. And if I go and refresh it, and I'm going to type I feel good, and we can see it shows this loader spinner, and I get the inference back. If I write sad, it's again showing the loader spinner, and it is going to load the emotion, the tags that denote the emotion. With that, our web page is done, and now we can proceed to publish it onto Vercel. Well, I just realized that this text box is actually not responsive. So when I increase the width of the page, the text box width remains the same. The text area is already taking the full width of the div, but we'll have to add a specific width based on the page width. So I'm going to add width 1/2. So that is basically setting the width, the container div's width as half of the page. So that way, if we increase it, it is going to increase with the page width. And also when the width of the page is very small, this is the half of the available space is actually very, very small. So we'll have to add a minimum width as well. So I'm going to add min w is going to be 80. That way the text box is going to have some width even if it's a very small screen. And when we are going to increase the width, it's going to take up more and more space in the page.